Hello friends, welcome to the session. The same chapter 2 itself, that is power semiconductor devices. In that I am discussing the concepts with respect to thyristor. In the last session I started what is the protection circuit of SCR, what is the protection provided using different elements against different abnormal operating conditions. Okay. Now the continuation of that concept is given for over voltage protection, which protecting element we are using, for over current protection, which protecting elements we are using, what exactly di by dt protection, what exactly dv by dt protection, then what is gate protection. All these concepts I discussed. Now we go for in detail about the concept of Snubber circuit. That is very important concept for competitive point of view. Okay. First we will see the concept of Snubber circuit. The first very important concept is the Snubber circuit. Snubber circuit. Okay. What is the purpose of using Snubber circuit? How to design the Snubber circuit parameters? These concepts I want to discuss. What is the purpose of using Snubber circuit? That I already told. So many applications are there for Snubber circuit. In general, the main purpose of using Snubber circuit is a Snubber circuit is used. A Snubber circuit is used to reduce or suppress dV by dt. To reduce or suppress dV by dt. Okay. That is the purpose of using Snubber circuit. But point to remember, a series RC circuit across the device is called Snubber circuit. A series RC circuit across SCR or across device is called Snubber circuit. Okay. A series RC circuit across the device is called Snubber circuit. For example, we are using the Snubber circuit to protect from dV by dt, to protect the thyristor from dV by dt. This is thyristor. Now you want to protect this thyristor from sudden change of dV by dt. This is some switch arrangement. This switch. Okay. And this is the thyristor connected. That the supply voltage is V. This positive, negative. This is capital V. For example, let us assume that the thyristor is under forward blocking mode. If the thyristor is under forward blocking mode means, it acts as a which one? Open switch. Let the thyristor is under forward blocking mode. It acts as a open switch. Okay. Now, if the suddenly switch is closed, if there is any large dV by dt, we are closed, switch is suddenly, switch is closed at, let us assume that at t equal to 0. If the switch is closed at t equal to 0, if there is any sudden change of voltage, that sudden change of voltage will appear across the SCR, then the SCR may be damaged. We are closed the switch, because of this transient voltage, because of that sudden change of voltage, that SCR may be damaged, because this voltage will appear across the device. Because it is under which condition? Off state. Under off state, it is under forward blocking mode. Now, we want to protect this device from sudden change of voltages. For that, no doubt at all, to protect the thyristor from sudden change of voltages, one single capacitor is enough. To protect the thyristor from sudden change of voltages, a single capacitor is enough. We know the property of capacitor. We can define the current through the capacitor IC equal to C into dV by dt. Tell me, at t equal to 0, what is IC? IC equal to infinity. Current through the capacitor is infinity. Current through the capacitor, t equal to 0, IC is infinity. Current through the capacitor is infinity means, current is infinity means short circuit. Then tell me, at t equal to infinity, what is IC? If you substitute infinity here, IC equal to 0. Current through the circuit is 0 means it acts as an open circuit. That means initially the behavior of the capacitor is short circuit. Initially the behavior of the capacitor is a short circuit means, the behavior of the capacitor is short circuit means what is the voltage across the what is the voltage across capacitor? 0. That means therefore capacitor cannot allows which one? Sudden change of voltages, because it acts as a short circuit. Cannot allows sudden change of voltages. Cannot allows sudden change of voltages. Already given what is the behavior of the inductor. Inductor cannot allow sudden change of current. That means initially inductor acts as a open circuit. But here we are telling that initially capacitor acts as a short circuit. Capacitor acts as a short circuit means it cannot allow the sudden change of voltage. Short circuit in the sense voltage is not present. Okay. Now tell me. Now in this case, in order to protect this SCR, just I am connecting one single capacitor. If the suddenly switch is closed, if there is any sudden change of voltages, because of this sudden change of voltages, now capacitor acts as a which one? Short circuit. Once it acts as a short circuit, then what is the voltage across the SCR? Ideally 0. Then is there any sudden change of voltage will appear across the thyristor? No. That means it is protected from sudden change of voltages. That's the reason why to protect the thyristor from sudden change of voltages, single capacitor is enough. But what is the need of connecting RC circuit? That I want to discuss. Okay. Initially capacitor acts as a short circuit. After some time, the capacitor charged to a voltage. With this is positive plate, this is negative plate. Let us assume that capacitor charged to a maximum voltage of V. Then after some time, the capacitor charged to a voltage V. This is positive and this is negative, because current is flowing like this now. Then with this polarity, capacitor charged to a maximum voltage of V. Now, if any triggering pulse is applied to the thyristor. Now thyristor starts the conduction. Yes sir. Now tell me. Now we are applying the triggering pulse to the thyristor. If any triggering pulse is applied to the thyristor, now what happens? If the triggering pulse is applied to the thyristor starts the conduction. Okay. Once the thyristor starts the conduction, there existed two currents. One is already existing current, that is nothing but a supply current, that is I, load current I. Along with there exists another current, that is the discharging current of the capacitor. This is the path for discharging current of the capacitor. Now, what is the capacitance current? The discharging current of capacitor IC equal to, the discharging current of capacitor IC equal to V by impedance offered in this path. But this is nearly equal to 0. If this nearly equal to 0 means the discharging current is high. Now, this very high discharging current is, and already there exists a source current and there exists a discharging current, and this is the source current. Because of these two currents, the SCR may be damaged. Because of this high discharging current of capacitor, that SCR may be damaged. Now what do you want to do here? Now you want to limit the discharging current of a capacitor. How to limit the discharging current of a capacitor? By increasing this impedance. By increasing the impedance path, by increasing the impedance in this path, this discharging current will be reduced. Now in order to increase the impedance in this path, I will connect one series resistance. That series RC combination across the SCR is called Snubber circuit. It's very simple. What I am telling? To protect the thyristor from sudden change of voltages, single capacitor is enough. But practically, don't connect a single capacitor across the thyristor, because a discharging current of capacitor will damage the SCR. In order to limit the discharging current of capacitor, a series capacitor is connected in series with a series resistance is connected in series with capacitor. That RC combination across SCR is called a Snubber circuit. Now, what you can do here? Then to limit this discharging current, to limit discharging current of capacitor, discharging current of capacitor, to limit discharging current of capacitor, a resistance is connected, okay, in series with capacitor, This RC combination, this RC across SCR, this RC combination across SCR is called, which one? Is called Snubber circuit. Okay, that is the purpose of using the resistance in series with capacitor. Yeah. Now, if you draw the exact circuit of Snubber circuit means, then this is some switch arrangement. This is thyristor. Then let Snubber circuit resistance is RS. RS is the Snubber circuit resistance. Let CS is the Snubber circuit capacitance. Okay. This RS and CS combination is called Snubber circuit. Let this is a switch arrangement. And the supply voltage is V. Okay. This is positive. Where the purpose of Ring, where RS is a Snubber circuit resistance. Snubber circuit resistance. Where CS is a snubber circuit capacitance. Snubber circuit capacitance. Snubber circuit capacitance. Okay, snubber circuit capacitance. The purpose of using RS is to limit discharging current of to limit discharging current of capacitor. Okay, to limit discharging current of capacitor. This is called a snubber circuit. This RC circuit across the thyristor is called snubber circuit. Now tell, what is the purpose of using resistance in series with capacitor? A resistance is connected in series with capacitor to limit discharging current of capacitor whenever thyristor is triggered. Clear? Now tell, actually when this resistance is required? During discharging of capacitor. But let us assume that if the thyristor is under forward blocking mode, whenever switch is closed, then the capacitor start to charging. When the thyristor is under forward blocking mode, whenever switch is closed, then the capacitor start to charging. Then capacitor is starts to charging with a positive, negative V. Capacitor is charging. But no need of any resistance during charging. But once we are connected the resistance in series with capacitor, that resistance is present during charging of capacitor and during discharging of capacitor also. But that resistance is required only in discharging, but during charging no need of any resistance. But during charging, if the resistance is present, what is the drawback, you tell me? Clear? When the resistance is required? During discharging. What is the purpose of using resistance? To limit the discharging current. But once we are connected the resistance in the circuit, in the charging time also it offers the resistance. During charging, if the resistance is present, what is the drawback? Yes, one drawback is it adds additional power loss. During charging time, if the resistance is present, it adds additional power loss. That is one drawback. Second drawback is then what is the time constant of RC circuit? The time constant of RC circuit here is RS into CS. Because of presence of resistance, then what is the time constant? Increases. When the time constant is increases, for charging of the thyristor, for the charging of the capacitor, not thyristor, for charging of the capacitor, it takes more time or less time? More time. Then to overcome this drawback, that means to bypass the resistor during charging of capacitor, to bypass the resistor during charging of capacitor. That means during charging, no need of any resistance. During charging, no need of any resistance. No need of any resistor. No need of any resistance. If it is present, what happens? It adds additional power loss. Additional power loss. Then another one is the time constant. RS into CS is increases. That is a problem. Now what you want to do? To bypass the resistor during charging of the capacitor. To bypass the resistor. To bypass the RS during charging of the capacitor. During charging of capacitor. During charging of capacitor. During charging of capacitor. A diode is connected. A diode is connected across RS. A diode is connected across RS. A diode is connected across RS. That is, to bypass the RS during charging of capacitor, a diode is connected across RS. This is a modified Snubber circuit. A diode is connected across RS. Okay. A diode is this is thyristor, is under forward blocking mode. Let us assume that. Okay. A diode is connected across RS. Okay. This is the diode. Okay. Now tell me. Let initially thyristor is under forward blocking mode. Initially the thyristor is under forward blocking mode. Now whenever supply switch on, then this capacitor will charges through diode or through resistance? Through diode, because diode offers the less resistance path. That's why the capacitor will charge like this. Now during discharging of capacitor, whenever thyristor is triggered, the capacitor will discharge us now. During discharging of capacitor, during discharging of capacitor, the capacitor will discharge through resistor, because diode cannot allow in the reverse direction. If the capacitor is discharges through resistor, then it limits the discharging current now. Then whatever this drawback is there, that can be overcome by connecting the diode. Okay, this is the modified Snubber circuit. Clear? This about what exact Snubber circuit of a thyristor. But point to remember, a Snubber circuit without diode is called unpolarized Snubber circuit. A Snubber circuit with diode connection is called polarized Snubber circuit. This is important. Here we are dividing the Snubber circuit into two types. A Snubber circuit. A Snubber circuit. A Snubber circuit without diode. Without diode. Without diode is called unpolarized Snubber circuit. Unpolarized Snubber circuit. Unpolarized Snubber circuit. This unpolarized Snubber circuit mainly used in thyristors. Used in thyristors. Unpolarized Snubber circuit mainly used in thyristors. Yes. A Snubber circuit. A Snubber circuit. A Snubber circuit. A Snubber circuit with diode. With diode. With diode is called polarized Snubber circuit. Polarized Snubber circuit. Polarized Snubber circuit. These polarized Snubber circuits are again two types. One is forward polarized. Forward polarized. That is backward or reverse polarized. A reverse polarized Snubber circuit. In forward polarized, diode is in the direction of thyristor. In the direction of thyristor. In the direction of thyristor. Okay. But in the case of reverse polarized Snubber circuit, diode is opposite to thyristor direction. Opposite to thyristor. The direction of thyristor, diode is opposite to thyristor. Then it is nothing but a reverse polarized Snubber. In detail, that's not required. When you concentrate on the direction of diode and thyristor is same, then it is nothing but a forward polarized. If that arrangement is, we can also make in the reverse direction, then that arrangement is nothing but a reverse polarized Snubber circuit. But another point to remember, unpolarized snubber circuit is used. If a thyristor consists of anti-parallel diode, then we can use the unpolarized snubber circuit. If the two thyristors are in anti-parallel, then we can use the polarized snubber circuit. Clear? If the thyristor consists of anti-parallel diode, then we can use the unpolarized snubber circuit. If the two thyristors are under anti-parallel connection, in some applications we also connect two thyristors on anti-parallel connection, then we can use the polarized snubber circuit. When you can use unpolarized and when you can use polarized snubber circuit, that you concentrate. But generally, in thyristors means we can use unpolarized snubber circuits. Okay, this polarized snubber circuits having the application in BJT, IGBT. In that application, this is having some applications. But mainly in the thyristor production, we can use polarized. But point to remember, this snubber circuit, not only for thyristor production, this snubber circuit is also used for to protect the transistor, or it is also used for to protect the IGBT. It is also used for to protect the diode. It is also used to protect the MOSFET. To protect the MOSFET also we can use this. That means here the device may be transistor, the device may be IGBT, the device may be diode, or the device may be MOSFET. Clear? That means the snubber circuit is not only for thyristor. The snubber circuit is also used to protect all the device. Even to protect the any switch arrangement also we can use the snubber circuits. To protect the switch also we can use the snubber circuits. Understood? But here I am talking about a protection circuit of thyristor. That's why I taken the thyristor device. This is SCR I taken. Okay, clear? Okay, this about what exactly snubber circuit, what is unpolarized, what is the polarized snubber circuit, when you can use forward polarized snubber circuit, when you can use a reverse polarized snubber circuit. Reverse polarized snubber circuit. Okay, clear? Concentrate on these points. Point of view, what the application of snubber circuit is? It may be polarized or it may be a unpolarized, whatever may be. Applications of snubber circuit. Okay. Applications of snubber circuit. One is L snubber. This also one of the sub. But general snubber circuit means you take RC snubber circuit. L snubber is used to reduce which one? Di by dt. This is one. RC snubber circuit is used. RC snubber circuit. RC snubber circuit is used to reduce which one? dV by dt. dV by dt. Okay. The another point you remember, one observation. Let's assume that thyristor is under forward blocking mode. Okay. Here we are using the snubber circuit, RC snubber circuit we are using. Okay. Now this is switch arrangement. Okay. Then this is the supply voltage V. We are using this supply voltage, positive, negative V. Yes. Yes. Listen please. For example, if the circuit is not present, if the circuit is not present, I am not discussing with respect to dV by dt. The another application I am discussing. What is the purpose of using this RC snubber circuit of another application I am discussing. Okay. For example, if the thyristor is triggered. Now this current is passing. Let this current is I1. This I1 current is passing through the thyristor. Then thyristor starts the conduction. Then once the thyristor starts the conduction, whenever the current is reaches to the latching current, then we can remove the gate signal. For example, let us assume that gate is connected up to this period. Then the current through the thyristor is reaches this I1 current is reaches to latching current at this period. Latching current, it reaches to, that this is latching current. This I1 current is reaches to latching current. Then this is gate is turned off. Okay, this IL latching current. Then we can remove the gate signal. This is the gate on time. This current is gate current. Okay. Now, if this thyristor consists of snubber circuit, what happens? The purpose of using snubber circuit is dV by dt protection. That you know. Clear? Now another application I am discussing here. Let this is R and this is C. Tell. This, whenever thyristor is triggered, now we are giving the thyristor is triggered. Whenever thyristor is triggered, now this is the current. This is the current. Let this current is I2. Now how many currents are passing through thyristor? Two currents. What is this current? That is I1 plus I2. Now this current is I1 plus I2. How many currents are passing through the thyristor is that is I1 plus I2. How many currents are passing through thyristor? I1 plus I2. Then whenever I1 plus I2, within less time, it reaches to latching current. This is I1 plus I2. Within less time, the current through the thyristor is reaches to latching current. Within less time it is reaches to latching current means then no need to apply a large gate pulse. Within less time we can remove the gate pulse. This is T, this is T. Then this is the gate pulse. Understood? See the concept. Because of one current is exist, then to reach the latching current it takes more time. That's why more time we are applying the gate signal. But whenever two currents are flowing, because of this snubber circuit, there is a discharging current of capacitor is also present. Now two currents are passing through the thyristor. To reach the latching current, it takes more time or less time? Less time. Within less time it is reaches to latching current. Whenever within less time it is reaches to latching current, what is the gating requirement? We can apply the gate terminal. We can connect the gate signal. More time or less time? Less time we can connect. Whenever within less time it is reaching to the latching current, for turn on of thyristor, it takes more time or less time? Less time. That's why this is the another application of a snubber circuit. That means a RC snubber circuit improves the turn on trajectory. It improves the turn on trajectory and reduces the gate signal on period and reduces the gate signal requirement. That means within less time, the thyristor will be turned on. Within less time, the thyristor reaches to latching current. That means because of this RC snubber circuit, within less time, thyristor reaches to latching current, latching current. Then another point is the gate signal on time. Gate signal pulse width is reduced. Gate signal pulse width is reduced. Pulse width in the sense I told already. This is a turn on time. Pulse width is reduced and turn on trajectory is improved. Turn on trajectory is improved. That means the turn on time is also reduced. Within less time it is reaches to latching current. That is another application of a snubber circuit. The another point to remember, the snubber circuit. The another point to remember with respect to snubber circuit. Okay. A snubber circuit equalizes the dynamic characteristics. That is, a snubber circuit equalize the dynamic characteristics. Later on in the series and parallel connection, I will give the proof also. Equalize the dynamic characteristics dynamic characteristics and equalize the voltage distribution across the SCRs. Equalize the voltage distribution across SCRs. And equalize the voltage distribution across thyristors or across SCRs. These are the applications. Yes. Okay. This about what is the application of Snubber circuit. That is, L snubber is used to reduce di by dt. RC snubber circuit is used to reduce dv by dt. This RC snubber circuit is also used within less time. Thyristor reaches to latching current. Gate signal pulse width is reduced. Turn on trajectory is improved. That means turn on trajectory is improved means within less time the thyristor will maybe turned on. A snubber circuit equalize the dynamic characteristics and equalize the voltage distribution across SCRs. Okay. This is what exactly snubber circuit. What is polarized snubber circuit? What is unpolarized snubber circuit? Where we can use unpolarized snubber circuit? Where we can use polarized snubber circuits? Okay. What is forward polarized snubber circuit and what is the reverse polarized snubber circuit? That you concentrate. This point is important. Note down this. This characteristics I given like this. Concentrate. Okay, clearly I am drawing here. Okay, let this I1 current. If only I1 is present, this I1 current reaches to latching current. This is IL, and this is the gate signal requirement. This much of time we can apply the gate. This is IC, gate current. Okay. Now both I1 and I2 is present. Both I1 and I2 is present. This is the gate on time. Okay. Both I1 and I2 is present. Means both this present. This is gate signal requirement. This is T on. This is IC. Then this is I1 plus I2. If I1 plus I2 is present, only I1 means this. I1 plus I2 means discharging current and supply current. Both are present. This time, within this time, the current is reaches to latching current. Yes. Like this we are getting. All these are the special applications of a snubber circuit. Now we'll see the next concept with respect to snubber circuit is how to design the snubber circuit parameters. Okay. Let's concentrate on design of snubber circuit parameters. How to design the snubber circuit parameters is there is one concept is based on that concept we want to design the snubber circuit parameters. Okay, is clear? The next concept is a design of snubber circuit parameters. Okay, go through with a design of snubber circuit parameters. Yes. You see, during the design of Snubber circuit parameters, okay, let us consider. Here I am designing this Snubber circuit parameters along with inductor. So also consider inductor. The purpose of inductor is to limit the di by dt. Along by considering the inductor also you are designing. Okay. This is thyristor. Taken this is Rs is the Snubber circuit resistance. CS is Snubber circuit capacitance. Let this is RL is load resistance. Let the supply voltage is V. This is positive and this is negative. Okay, the supply voltage is V. Now we concentrate on design of Snubber circuit parameters. One way to write these formulas. Here I am giving two concepts. Okay, one way to write the formulas is directly. Okay, let yes, you know that V equal to L into di by dt. V equal to L into di by dt. Now from this you design what is the di by dt. Di by dt is designed as V by L. This is design of di. Or from this we can design the inductance. Okay, di by dt inductance. This L is designed as L equal to V by di by dt. Let the discharging current of capacitor is IC. If the discharging current of capacitor is given, then what is IC equal to C into dV by dt. From this also we can design the capacitance. IC equal to C into dV by dt. We know that. Let us assume that the instantaneous voltage across the capacitor is written as instantaneous voltage across the resistor is written as V equal to I into Rs. Then differentiates both sides. Then dV by dt equal to di by dt into Rs. Then what is di by dt? You tell me. From this di by dt equal to V by L. Then you write dV by dt equal to V by L into Rs. Then from this you define Snubber circuit resistance equal to L by V into dV by dt. L by V into dV by dt. Snubber circuit resistance Rs equal to L by V into dV by dt. Then we are designing Snubber circuit inductance. If discharging current is given, by using this formula you can define capacitance. Then you can design Rs. If damping ratio is given, because it is one of the RLC circuit now. It is one of the RLC circuit now. For RLC circuit is nothing but a second order. We can form the second order system equation, because RLC, how many storage elements are there? Two storage elements. Two storage elements means we can form the second order system equation. By solving that second order system equation, directly I am giving, no need of derivation here, directly I am giving, by solving that second order system equation, then if damping ratio is given, if damping ratio is given, then the value of Snubber circuit capacitance CS equal to 2 zeta by Rs plus RL whole square into L. This is the value of Snubber circuit capacitance, where zeta is the damping ratio. In Snubber circuit, the value of zeta equal to 0.5 to 1. Then for optimum results, if it is not given, for optimum results, take zeta equal to 0.65. 0.65. Take zeta equal to 0.65. This is the design of Snubber circuit inductance, Snubber circuit capacitance, Snubber circuit resistance, Snubber circuit capacitance. Like this we can design. But this I am giving final formula. Therefore summary I am giving. This is summary I am giving. Summary I am giving here. Then what is the inductance? L equal to V by di by dt. What is Snubber circuit resistance? Rs equal to L by V into dV by dt. What is Snubber circuit capacitance? Cs equal to 2 zeta by Rs plus RL whole square into L. Okay, if RL equal to 0, if load resistance is not given, if load resistance is not given, take Cs equal to 2 zeta by Rs whole square into L, where RL is the load resistance. This is the load resistance. This is load resistance. That point you concentrate. If RL is not given, take the load resistance equal to 0. This is the Snubber circuit capacitance. Okay, but practically, always take that is RS is greater than design value. Okay, CS is less than design value. L is redesign. Okay, but during design, RS is always you take greater than the design value for effectively limit the discharging current. CS is less than the design value to limit the discharging current of capacitor. L is redesigned by using this formula. Using this formula, we can redesign. Okay, this about design of Snubber circuit parameters. Okay, this is the concept of protection circuit and Snubber circuit. Okay, now based on this concept, in our classroom workbook, in another we want to solve some problem. Later on we will see. Okay, this mainly these formulas you concentrate. How to design the inductance, capacitance and the resistance. Clear?